Hello everyone, I would like to present our project titled Learning with Human Motion Tracking Using Camera. Our group members are me, Lim Yasheng, Akil Zahwan bin Razaidi, Muhammad Harif bin Samsul Bahrin, and finally Aina Raihana binti Muhammad Tazim. I would like to move on to the Sustainable Development Goals of our project.
Okay, now I will talk about sustainable development goals that covered by our project. First one is SDG 3 regarding to the good health and well-being. It's one of 17 sustainable development goals established by the United Nations in 2015. The official wording is to ensure healthy lives and promote well-being for all at all ages. The targets of SDG 3 focus on various aspects of healthy life and healthy lifestyle. Progress toward the target is measured by using 21 indicators. SDG 3 aims to achieve universal health coverage and equitable access of healthcare services to all men and women. Next, SDG 4, which is quality education, is the United Nations commitment to ensuring inclusive and equitable equality education and promoting lifelong learning opportunities for all by 2030, aiming to provide free primary and secondary schooling, equal access to affordable vocational or higher education, and reduce skill gaps. It addresses disparities by focusing on access, equity, skill for work, quality, with targets for early childhood to adult learning using technology to bridge gaps. Next is SDG 9, which is industry, innovation, and infrastructure. It's a United Nations Sustainable Development Goal focused on building resilient infrastructure, promoting inclusive and sustainable industrialization, and fostering innovation to drive economic growth and development for all. It aims to ensure universal access to technology, communication, financial services, while upgrading industries for resource efficiency and sustainable practices. Next, we proceed with identifying problem. Many students experience low learning engagement due to passive and screen-based learning methods. Limited physical movement during learning leads to poor posture, fatigue, and reduced well-being. Next, lack of interactive and affordable learning technologies in schools and community learning spaces. Based on our supporting evidence, which is the first one, refer to Malaysia's STEM student enrollment from 2020 until 2024. During 2020, the enrollment percentage is 47.18%. For the 2021, the enrollment percentage is 40.95%, and then 2022, 40.94%. For 2023, 45.73%, and for the 2024, it is 50.83%, which is below the national target, that is 60%. For your information, STEM or STEM refer to science, technology, engineering, and mathematics. One key point about science is understanding the natural and physical world through observation and experimentation. Technology, using scientific knowledge to create tools, machines, and systems. For engineering part, designing and building structures, machines, and systems to solve problems. For mathematics, the foundation for logic, problem solving, and analyzing data across all system fields. It is important because to meet high demands for skilled professionals in technology, digital, and other strategic sectors. It also important in terms of innovation, like AI, clean energy, and digital technologies. Also, for skill development, with essential skills like critical thinking, problem solving, and analytical abilities. Next, we proceed to the second evidence, which is prevalence of limited health literacy among Malaysian adults, which is it show 51.4% know or excellent in literacy, and the other 48.6% is limited health literacy, which is the health literacy is the ability to find, understand, use, and apply health information and services to make an informed decision for your own and others' health, involving skills like reading, critical thinking, and navigating healthcare system. It is crucial for everyday tasks like understanding medicine labels, communicating with doctors, and completing insurance forms. And here is our reference that consists articles and news for our supporting evidence.
Now, I will present about the proposed solution. This system will detect the user's body and also the right hand position that is pointing to that specific part of the user's body. And then the learning information about the selected body part will be displayed accordingly. This system is powered by Python code with Python libraries such as NumPy, MediaPipe, and OpenCV. MediaPipe is a library developed by Google for visual solutions. This system uses a camera to operate and also read the data from the video. Since this system is software-based, it can be improved, modified, and even scaled for future needs. In the future, if the technology improves, the proposed solution can also improve as well. Next, I would like to go into the flowchart and explain the process of our solution. We start by running the Python code, and initially, the Python libraries will be initialized. For example, the NumPy, MediaPipe, and OpenCV will be initialized. After that, it will open the user's webcam, whether it is through computer, laptop, or external webcam. After that, it will read the video frame one by one. During that time, it will detect the user's posture in real time. Using this user posture, it will draw the pose landmarks and also index the landmark. It will extract the right hand and index landmark position, for example, the right shoulder, head, and heart position. Using these positions, it will calculate the distance between the right hand and the index landmark. To calculate, this is done in order to calculate if the right hand is touching or approaching the index landmark. If the right hand touches the index landmark, then it will display information about the selected body part. For example, if my right hand touches the heart, it will display information about the heart. This loop will continue. After displaying the information, it will read the video frame again, detect the posture, and draw the pose landmarks until the user presses Q to quit the program. Then the program ends. That is all for the flowchart of our solution.
Now, I'll explain how we achieve the selected SDG, specifically SDG 3, 4, and 9. For SDG 3, which focuses on good health and well-being, the system increases health awareness by helping users identify body parts and providing simple health advice, allowing users to better understand and care for their bodies. For SDG 4, the project supports quality education by offering an interactive learning experience through AI-based body tracking, which improves student engagement, understanding, and memory compared to traditional textbook learning, while also promoting digital literacy and STEM skills through the use of programming and computer vision. Lastly, for SDG 9, the project promotes industry innovation and infrastructure by using computer vision technology and low-cost hardware, such as laptop, webcam, to create an innovative and cost-effective educational tool that modernizes traditional teaching methods and supports inclusive digital classrooms.
Okay, next we move to future target. Our project is all about using cameras to track human movement for learning. Our first big goal is to make the system smarter using AI. Right now, the camera just sees movement, but we want to add AI-based motion recognition so it can understand exactly how a person is moving. This means if you are practicing a specific skill, the system can give you precise feedback, almost like having a digital coach tell you how to improve your form instantly and give you information. Next, we want to take this tech out of the lab and into the real world. Our goal is to expand across Malaysia, placing these systems in schools, rehab centers, and community space. We want to make sure everyone, even in rural areas, can use this for education or physical recovery. To make it more accessible, we are building a mobile and web platform. This is a game changer because it means you won't need a fancy equipment. You can just use your phone or laptop camera. This makes remote learning easy for everyone, no matter where they are. Finally, we want this to be affordable and sustainable. We are focusing on a low-cost, energy-efficient design. We don't want this to be an expensive luxury. We want it to be a tool that any school or clinic can afford to buy run without high electricity bills or expensive hardware. By keeping it low cost, we ensure that this technology can be used for years to come without breaking the bank. So, by combining AI accuracy, nationwide reach, mobile access, and low cost, we are creating a learning tool that is smart, easy to use, and available to all Malaysians.
Alright, now I'll continue with the survey results. We got a total of 25 respondents about learning human body parts and the difficulties they experience. Many students find it hard to remember the body part names, confuse similar parts, and struggle to visualize them. While some also face language and learning material challenges. Most respondents, about 68%, are very open to trying new learning methods, showing a positive attitude toward interactive and innovative approaches. The most challenging aspect of learning is understanding the function of each body part, reported by 44% of respondents, followed by remembering names, identifying parts in diagrams, and connecting them to real-life health issues. In addition, 76% of respondents said that physically pointing to body parts during learning helps them remember better. Furthermore, for question 5, you can see that around 80 to 85% of respondents agreed or strongly agreed that interactive and technology-based learning makes lessons more engaging and easier to understand, indicating strong overall support for these learning methods. Lastly, description on impact. This section describes the impact of the proposed system in terms of economic, social, and environmental aspects. Economically, the low-cost camera system uses affordable hardware, which helps reduce learning equipment costs and makes it suitable for schools and community learning centers with limited budgets, while also supporting innovation in educational technology and creating opportunities in the technology sector. Socially, the systems makes learning more fun and interactive by allowing students to learn through movement-based activities, which supports different learning styles, encourage physical movement, and promotes healthier posture during learning. It also supports inclusive and quality education by relying on digital and electronic resources rather than traditional methods. Environmentally, the system uses energy-efficient technology and reduces paper usage by minimizing reliance on printed materials, helping to lower waste and support sustainable and environmentally friendly educational practices. So that's all from us. Thank you for your attention.